So now we are describing the distribution numerically. So we discussed the location, the center. Where is the distribution? The second topic will be the shape, the measure of the variations. Is it fat or thin? The shape of the distribution. That is the second topic to describe the distribution. So we are going to take the sample variance first. We are going to take the sample variance, sample standard deviation, and the range. Another three statistics for the variations, the spread. The first one is the sample variance. For the sample variance, look at this. Yeah. Do you like it? No, yeah, it's horrible. Yeah, please don't look at this. Let me delete, right? Let me make this one bigger. Yeah, here. It's not this one. This one. Yeah, please erase everything. Okay. Except this one. I will give you 5 steps. Yeah, don't be afraid. You know, mathematical notation, mathematical formula is nothing. It's nothing. We are going to take one by one. I will give you 5 steps to get the variance. Okay? In the first step, we can take the mean. You know, the notation, the x bar is something bar. It is the mean. It is a notation in statistics for the mean, something bar, x bar. Step number 1, take the mean. So let me go back the table. Here is 5 heights. Let me see just a second. Heights. Numerical or categorical? Heights. Numerical, thank you. Can you take the average? Step number 1, we can take the mean. Please take the average. Step number 1, average. Take the sum, 72, 73, 76, 76, and 78, and then divide it by 5. How much? 75 even? 75 even, thank you. It is a step number 1. Let me look at the formula. Okay, so we took the mean. And then step 2, take the difference. Xi. You know, when we saw the formula for the mean, we took the sigma sum of the xi's. What was the notation for the xi's? For each value. So now, okay, let me go back. Oops. Let me go back to the, what's wrong? My God, just a second. Let me go back, please. I have no idea. Yes. Yes. I hate technology. You know, yes, you are here, okay. Second step, we take the difference, xi minus x bar. That means 72 minus the mean 75. 73 minus 75. 76 minus 75. 76 minus 75 again. And the last one will be 78 minus 75. Take the difference. It is a second step. 72 minus 75 will be negative 3. Negative 2. Positive 1. Positive 1. And positive 3. How many steps did I say? I will give you how many? 5 steps. Thank you. Next. What? Take the square. So in step 3, already we took the difference. Now, take the square. Remember, when we take the square, every single value will be positive. So negative 3 squared, how much? 9, thank you. Negative 2 squared? 4. Plus 1 squared? 1, yes. 1 square again, 1. And 3 square? 9 again. Step number 3. Next, 4. Sigma again. What does that mean in math? Take the sum. Yes, take the sum. Step 4, take the sum, please. 9, 4, 1, 1, 9. 1 and 9 will be 10 twice. The sum will be 24. How many steps? 5 steps for the variance. Finally, divided by n minus 1. What was the n? For the mean, the number of values. How many numbers we have now? 5. Minus 1 will be 4. So we have to do in step 5, 24 minus, divided by 5 minus 1. 4. How much will be? 6. Who is this? The variance. The sample variance. Oops. Sample variance, yes. We are using the notation S square. The sample variance, S square. Good? It is the first statistic for the variation. Sample variance. But when you look at the formula here, right? Can you see the notation there? You know, I'm afraid. Yeah, see, I hate it. Yes, good. Yeah, just a second. Yes, here it is. What is the notation there? It's not S, but it is not S squared, but it's just S. You know, we applied 5 steps. We applied the 5 steps. What? In step number 1, we took the mean. In step number 2, we took the difference. Step number 3, square. Step number 4, take the sum. Step number 5, divided by n minus 1. For whom? The sample variance. But now there is one more step, the square root. Actually, it is in the step number 6 to get just S. You know, the variance had the notation S squared, but now we take the square root, the symbol, it will be just S. It is the sample standard deviation, the second one. The second one here, sample standard deviation. You know, the sample variance and standard deviation, that is the father and son, yeah. Because, you know, we just apply 5 steps to get the variance, and then just to take a square root to get the standard deviation. It's the same thing. It is the same thing. By 6 steps. It's additionally one more step, number 6. Take the square root. It will be the standard deviation. And the last one is a range. You know, the range is a very simple one. The maximum minus the minimum. The biggest value minus the smallest one. The maximum minus the minimum. Who was the tallest one? You know, actually we had 5 heights. Who is the tallest one? 78 minus the shortest one? 72. Then how much will be the range? 6, yes. What they are? Measure of the variations, the measure of the size, spread. 3 statistics. Variance, standard deviation, and the range. Another 3 statistics. It's good? Okay, then now, let me ask you. By 5 steps, we took the variance. Additionally, one more, simply just take the square root of the variance. We are going to take another statistic, another name, standard deviation. Why do we need the standard deviation? You know, simply just to take the square root of the variance, it will be the standard deviation. So if I got, you know, in this case, the variance was the 6, square root of 6. How much will be the square root of 6? 2.45. If I got 9 for the variance, how much will be the standard deviation? 3. How about 16? 4. 49. 7. 100. 10. It's the same thing. When we had bigger variance, then we are going to have a bigger standard deviation. The smaller one, it will be smaller one. Why? Isn't enough? The variance? Why we need another statistic? It's almost the same, right? Isn't it? It's 1-to-1. It's almost the same statistics. Why? Think about this one. You know, actually, we had height. 72, 73, 76, 78. How do you think? What is the unit? What is the unit for the height in this example?
Inches.
Inches, yeah, must be inches. When I take the average, you know, in step number 1, we take the mean, right? Average. What will be the unit for the average? The average was 75. Unit will be inches again. Does it make sense, right? 75 inches on average. We had a variance 6. What is the unit for the variance? No, sorry. It's not inches. Squared inches. Why? In the middle of the steps, step number 3, we took square. So the unit for the variance will be squared inches. What is that for? Is the height? No, it is the area. You know the square foot, square inches. It is not a unit for the length, but area, another unit. But when I take the square root of it again, you know, the square root of 6 was a 2 point something, right? The 2.45 standard deviation. What do you expect? What will be the unit for the standard deviation after take the square root of it? Inches again. You know, sometimes we have this kind of notations. Something plus and minus something. Have you ever seen that kind of statement, something, right? The first thing is, most of the time, is a mean, average. And the second one, that is a standard deviation most of the time. And we added subtract, plus and minus. They must have the same unit. Variance is enough to measure of the variation, the measure of the spread, but the unit is different. So we have to take square root again, because in the middle of the 5 steps, in step number 3, we took the square. So finally, in step number 6, we have to take the square root again. It's good? So that is the reason why we have almost the same 2 statistics, the variance and the standard deviation. But yeah, that is a little bit different. And the range is the simplest one. And a little bit more. Okay, let me clean up. We had 5 heights. Who are the 5? 72? 72. Okay, just a second. Here is 72, and the tallest one is 78. So 73, 4, 5, 6, 7, 8. And 74, 76. Okay, so how many 72s? Just one? One. Next. Let me make the dot plot. Do you remember the dot plot in chapter 2? Okay. The second case? 73. Next. 76. Next. 76. Oh, 6 and one more. Okay, good. And then 78. Good. We had 5 heights. In step number 1, we took a mean. How much was the mean?
75.
In step number 1, the mean was 75. Thank you, 75. X bar. That is the mean. Something bar, X bar, 75. And in step number 2, what we took? In step number 2, we took the difference. 72 minus 75, 73 minus 70. You know, actually, the difference, subtraction in math, actually that is the distance. That is the distance from the case to the mean. So 72 minus 75, the difference was a negative 3. It's actually the distance was negative 3. The distance up to 73, it was 73 minus 75, negative 2. And up to 76, the distance was positive 1. And we had another positive 1. And the last one, to the tallest one, 78, the distance was positive 3. In step number 2, we took the distance, the difference. What we did in step number 3, we took square. Because of that, in step number 6, we took the square root to get the standard deviation, right? In step number 3, we took the square. Just a second. Why we took square? How do you think? Why? In step number 3. What we are doing? We are measuring the variation, right? In step number 3, we took square. Why? What happened after we took the square?
We have the numbers positive.
They'll all be positive. Yes, it is. I want to make all positives. What we did in step number 4, take the sum, right? Why don't you try to take the sum without square? Please take the sum. -3, -2, positive 1, 1, and 3. Please take the sum without square. Please try. How much will it be?
0.
Nothing. What we want to do? Measure of the variation. But without square, just take the sum, nothing. We must make them all be positive. That is step number 3, square. But we have to go back. In step number 6, take the square root. So in step number 3, we took the square. So it will be 9, 4, 1, 1, and 9. And then take the sum, divided by n minus 1. Finally, in step number 6, take the square root of it. Take the standard deviation with the same unit. So can you understand why we take the difference? Because we measure the distance from the mean. What was the mean for? The center. The center of the distribution. So please remember what we are doing. We are measuring the variation. We are measuring the size. So the very first step, we took the mean, center, and then take the difference, the distance from the center, and take the sum. We must take the sum, but yeah, we need all positive, and divide it by n minus 1. And then square root. So by the 6 steps, we take the standard deviation. For what? Again, the measure of the spread, the measure of the variations. It's good? Okay? So the variance and the measure of the standard deviations are almost the same, yeah, by 5 steps or 6 steps. And then additionally, we had one more statistic. It's named the range. It's good? Okay, one more. Let me take the formula, the ugly formula for the variance, which was we take the mean, difference, square, summation, divided by n minus 1. 5 steps for the variance. It's good, right? I ignored the last step. Okay, let me erase them. Actually it was the variance. I told you the notation is s squared. Now I erase is lots of things. How do you think? Who is this? Sum over n. What's that? You knew it.
The average.
The average, the mean, yes. What does it mean? Actually, the variance, it is the mean. It is an average. Just a second. The variance, standard deviation, were for the measure of the spread, the measure of the variation. But now, it has the form of the mean, average. Yes, it is. Actually, the variance, it is an average of what? The distance from the mean, from the center. It is a squared, the average of squared distance from the mean. For what? Measure of the variation. It is the mean. It is the mean. But what we did? Divided by not n, but n minus 1. Do you know why? Please don't ask me. I will explain to you later. Don't drop it. Maybe 2 weeks later. Yeah. I will explain to you. Just to do it. Minus 1 divided by n minus 1. Don't ask me. Yeah. I will tell you later. It is very important. Okay. So just to do instead number 4, we should divide it by not n, but n minus 1. And then take the square root. Just a second. Instead 5 divided by n minus 1. Instead number 6, take the square root to get the standard deviation. Sounds good?